Respected ma'am, myself Shraddha of CSCF. Today, the concept video that I got is laser modes, longitudinal and transverse modes. What is a laser mode? So, introduction to laser mode. Laser modes are essential for understanding how lasers operate. They can categorize into two primary types, longitudinal and transfer modes. Each mode has its distinct characteristics that affects the laser's performance. So basically these laser modes are of two types, longitudinal and transverse. This is the topic that we are going to talk on today. So coming to the first is longitudinal modes. Longitudinal modes refer to the standing waves pattern along the length of the laser activity. These modes are determined by the resonance conditions set by the cavity's boundaries. The spacing between longitudinal modes is directly related to the speed of light and cavity length. The longitudinal modes refer to the standing waves and the transverse waves refer to the horizontal waves. And In the longitudinal modes, this refers to the standing waves of the pattern along the length of laser cavity. These modes are determined by the resonance conditions by the cavity's boundaries. The spacing between longitudinal modes is directly related to the speed of light and cavity length. Characteristics of longitudinal modes. Longitudinal modes are quantized, meaning only certain frequencies can exist. Each mode corresponds to a specific frequency of light emitted by the laser. The frequency difference between adjacent modes is known as the free spectral range. These longitudinal modes are quantized. Um, each mode of these longitudinal modes correspond to a specific frequency of light emitted by the laser. The importance of longitudinal modes. The selection of longitudinal modes affects the laser coherence length. The coherent length produced by these modes is critical in applications like holography. Understanding these modes is essential for optimizing laser design and performance. In this longitudinal modes, the selection of the longitudinal modes affects the laser's coherence length. Uh, this rather than uh, opposing the transverse modes. In this longitudinal modes, coherent light produced by these modes is critical in applications like holography. Understanding these modes is essential for optimizing laser design and performance. Coming to the transverse mode describe the intensity distribution of laser beam across a cross section. These modes dictate the beam's shape and quality, which are crucial for various applications. These common transverse mode is the Gaussian mode, categorized by a bell-shaped profile. Transverse modes describe the intensity distribution of the laser across a cross section of the laser beam that is taken. The most common transverse mode is Gaussian mode. It is a bell-shaped profile. Transverse mode describe the intensity distribution of the laser beam across a cross section. Characteristics of transverse mode. Transverse mode can be further classified into transverse magnetic modes. Each transverse magnetic modes, which in term called as TEM, has a specific number of nodes and antinodes in the beam. Uh, Higher order transverse modes have complex patterns and reduced beam quality. The importance of transverse modes. The quality of the transverse mode affects focusing capabilities and laser efficiency. Transverse mode behavior is crucial in applications like laser cutting and medical devices. Understanding these modes help in developing laser for specific uses such as industrial and or medical applications. Um, Lo- to know the difference between longitudinal and transverse modes, in this longitudinal modes are referred to the laser cavity length, while transverse mode relate to the beam shape. We have already seen that the beam bean shape is Gaussian mode. Gaussian mode is bell shaped. Uh, Both modes are vital for determining the overall performance of laser light. Both are important for the laser system rather than longitudinal or transverse mode. The interplay between longitudinal and transverse modes can lead to the complex laser behaviors. More competition, which is better. In some laser designs, multiple modes can be compete for power, leading to instability. Understanding the mode competition is a key for optimizing laser output. Technique like optical feedback can help manage and stabilize mode behaviors. Applications of longitudinal modes. Now, getting into applications of longitudinal modes. Longitudinal modes are essential in spectroscopy, which precise frequency control is in which where the precise frequency control is needed. They play a crucial role in laser communications, affecting the data transmission rates. Understanding longitudinal modes can improve laser designs and enhance performance in various fields. Application of transverse modes. Transverse modes are crucial in imagining applications affecting resolution and focus. In machining, the mode quality determines the precision of cuts and engravings. Medical laser benefit from specific transverse modes to ensure effective treatment. Measurement techniques. Various techniques exist to measure longitudinal and transverse modes in lasers. Spectroscopy can be used to analyze longitudinal mode, and beam profiling techniques can uh, analyze transverse mode profiles. To know the future trends in the laser modes, this laser modes advances in laser technology aim to control both longitudinal and transverse modes more effectively. Research into new materials and cavity designs is ongoing to enhance mode performance. The development of hybrid lasers can may combine advantages of different modes for unique applications. Uh, the summary of longitudinal and transverse modes is longitudinal and transverse mode play integral roles in laser operation and applications. We have already seen the applications of the longitudinal modes and transverse modes. Longitudinal modes is essential in spectroscopy. The spectroscopy is used to analyze the longitudinal mode frequencies, and this longitudinal modes also play a vital role in laser communications affecting data transmissions, which are used in phone calls. Understanding longitudinal modes can improve laser designs for enhanced performance in various fields. uh, Applications of transverse modes, as we have already seen, these are used in medical fields to ensure effective treatments. Transverse modes are crucial in imaging applications. In laser machining, the transverse modes are used. The both type of modes can significantly influence the laser output quality. Understanding those modes is crucial for the ongoing advancement of laser technologies. A person should understand both longitudinal modes and technical modes to uh, for the ongoing advancement of laser technology, which is very um, important in future trends. As we have already seen in future trends, this laser modes are used in research into new materials and cavity designs, uh, which is going to ongoing to enhance more performance. Advances in laser technology aim to control both longitudinal and transverse modes more effectively. The development of hybrid lasers may combine advantages of different modes for unique applications. So, to conclude, longitudinal modes and transverse modes both play integral roles in laser operation and applications. Without these two modes, a laser operation cannot be performed. So, this is my idea on uh, longitudinal modes and transverse modes of laser. Thank you.